So what we're going to look at now is sine, cos and tan, and we're also going to look at Pythagoras' theorem later on in the video. So to begin with sine, cos and tan, these are only ever used in right angle triangles. So that's when one of them is a right angle and we have the sides and angles as well. So the rhyme we all must know is silly old Harry, so that's OH, cot a herring, cos is adjacent over hypotenuse, trawling off America. So that's opposite over adjacent. Now this is really important. At the start of every question, we should be writing that down. Silly old Harry, caught a herring, trawling off America. And they are three trig ratios. We're going to look at three different questions and we'll show us the three different ways that these come up. So focusing in on the first one first, we're going to see that we have 20, x, 10. We don't know anything about this side. We do know it's a right angle triangle. So first thing we always do is we label them as your hypotenuse because it's across from the right angle. And we'll label this one as your opposite because it's across from the given angle in the question. And your last one there is your adjacent. In this particular question, we wouldn't need to label it because what we have is we don't need it, we don't have anything for it, and it's not what we're looking for in the question. So here I have my hypotenuse and my opposite. So that would match up to sine. Sine is opposite over hypotenuse. So for the first one, I would say it's sine 20 equals silly old Harry, so opposite over hypotenuse. So that's sine 20 equals x over 10. Now to get x by itself, the 10 goes to the other side and multiplies because it was divided on this side, times by sine 20 equals x. And we'll be able to use our calculator to answer that. So we will say 10 times sine 20. So our answer is 3.4, correct to one decimal place. So x equals 3.4. Now that's the easiest way that we use sine, cos and tan, and the easiest way for it to come up. What we're going to look at next is this triangle here. Now this is also a right angle triangle, it's just orientated slightly differently. I have an angle and I have one side and I want to find the other side. So we're going to label the sides again. So this is across from the right angle, which makes it the hypotenuse. Now this would be my opposite because it's across from the 30 degrees, which makes 4 my adjacent. So your adjacent is between the right angle and the given angle in the question. So that is my adjacent. Now, I need to find my hypotenuse. I have my adjacent. So adjacent hypotenuse would be cos, because cos is adjacent over hypotenuse. Now this would be cos, and it's going to be 30 this time, because that's the angle. So cos 30 equals adjacent 4 over hypotenuse x. Now the difference between this question and this question is obviously we're using sine then cos, but the unknown was above the line in the first one. This time the unknown is below the line. So what we will do is we will say x will come up and it will be x by cos 30 equals 4. And our next step here then will actually divide the cos 30 by the 4. So it will be x equals 4 divided by cos 30. So x is 4 divided by cos 30. We will say it's 4 over cos 30. And we can close the bracket just to make sure it works. And that gives us 4.6 correct to one decimal place. So x equals 4.6. Now that's the second way it comes up. First of all, it's cos, which is our second one. But it's when the unknown is below the line. There's kind of an extra step here where the x comes up. Then you divide the cos 30 or whatever it would be by the number on the other side. Now our final one before we go on to Pythagoras' theorem is when we don't know the angle of the triangle. So in this case, I do not know what A is equal to. Now I know it's a right angle triangle, I have two sides. So I'm going to do the same as always, I'll label both these sides. Now that's my hypotenuse, but I don't have that side and I have no interest in it. But across from it is your opposite. So that's across from the given angle. Now in this particular case, we don't know the angle, but it's the angle of question or the angle that's given to us in the question. And 7 would be your adjacent because it's between the right angle and the angle here. So which one, sine, cos or tan? We'd use tan in this case because that uses opposite and adjacent. So I will say tan of the angle. So the angle is A equals opposite over adjacent. Now what I have here in the first one, I didn't have the number above the line. In the second one, I didn't have the number below the line. In the third one, I don't have the angle. So I have the number above and below the line, but I don't have the angle. So what we do here is we keep A. That's what I'm looking for. That's my angle. And I say A equals tan. But tan has changed side. So I would say tan inverse 5/7. So tan inverse 5/7. And depending on your calculator, if you have a Casio, you'll say shift tan. That gives you tan inverse. Or else you'll say second function tan if you don't. And that will be 5/7. And we'll close the bracket just to be sure. So it's 35.5, correct. To the nearest whole number, we'll say that angle A equals 36 degrees. Now, there are three ways. First of all, we use sine, cos, and tan. But this is when we don't know the letter above the line. This is when we don't know the side below the line. And this is when we don't know the angle in the question. Now, we're going to move on to Pythagoras. And there's two ways Pythagoras' theorem comes up as well. And Pythagoras' theorem is in your log tables on page 16, and it says c squared equals a squared plus b squared. Now you can learn off this way. My recommendation would be to learn off Pythagoras' theorem as h squared equals o squared plus a squared. Now the reason for this is hypotenuse squared equals opposite squared plus adjacent squared. In your log tables it says c squared equals a squared plus b squared. Either way, the most important thing that you do is the number by itself. So the h squared or the c squared, that has to be your hypotenuse. So we'll have a look at this question here first. And we're going to say this is my hypotenuse. And I know that because it's opposite the right angle. And this would be my opposite or this would be my adjacent. It won't make a major difference in this. So I'll say x squared for hypotenuse squared equals 3 squared. Plus 4 squared. Now, if you said 4 squared plus 3 squared, you'd still get the correct answer. So it's x squared equals 3 squared is 9 plus 4 squared is 16. So that's x squared equals 25. And x equals the square root of 25. So the square root of 25 is equal to 5 on your calculator. Okay, and you can type that in as well. So that means side x, the hypotenuse, x equals 5. Now, the other part is when we know the hypotenuse. So I'm trying to find either the opposite or the adjacent, whatever you want to call it. But I'm finding the side that is not your hypotenuse. So this is my right angle. And we still do the same thing. So h squared or c squared, but h squared, so that'd be 10 squared equals 7 squared plus x squared. Now, we'd always square these out first, just so we don't make a sign mistake later on. So that'd be 100 equals, now 7 squared gives you 49 plus x squared. So our next step is we have to figure out what x equals. So that'd be 100 minus 49 equals x squared. And then you're going to say 100 minus 49 gives you 51 equals x squared. So x equals the square root of 51, and we're just going to maybe do that here. So x equals square root 51. And on your calculator, square root 51 will give you 7.1, we'll say. Correct the nearest whole numbers. Correct to one decimal place. So that gives you 7.1 as your answer.